And the topic of this talk is automated machine learning. And the idea behind this approach and some examples, I will use Azure Machine Learning Services, okay, for this. So thank you for being here. Thank you for sponsors, organizers, a lot of people working together to make it happen. And I'm Marcin Szeliga. I've been working with Microsoft Data Platform Technologies for quite some time. So I wrote about those tools. Maybe you have seen this data science and practical and machine learning book. If so, I'm happy. Hopefully you haven't seen this one, Practical Machine Learning, because it's not published yet. But it will be soon. Ensemble code is on GitHub, so if you are more R or Python or SQL-oriented person, I will give you a link at the end of the session. And the last important part of information on this slide is my email address, marcinszeliga@datacommunity.pl. Please stay in touch with me. Okay, so machine learning. I started a few moments ago asking you who is actually machine learning practitioner, and there were like 2 guys saying, yes, I'm doing this, and 1 more, I'm playing with machine learning. But machine learning right now is it's a huge topic. Yeah? You can find it everywhere, not only in IT. I came here from Krakow, yes, from the security conference where I was talking about using AI in data cybersecurity. And cybersecurity is just one of many practical appliances of machine learning right now. So I'm pretty sure you are in touch with machine learning this way or another. Yeah? But maybe, probably, most of you know that to build a good machine learning system, a model, so the performance of this model depends on plethora of designing decisions. First of all, you have to choose the learning algorithm, then tune this algorithm, so build the structure of the model. And probably you should also spend some time preparing your data. And they are saying that if you change one thing, you will change the whole system. And this is very true for machine learning experiments. So if I changed one of many of those decisions, designing decisions, I will have to start from scratch evaluating the model performance. Okay? So one small change here can have a huge effects everywhere. So, theoretically, machine learning is about learning from data. But right now, it's a lot of manual work, a lot of code to be written to achieve this. Isn't that ironic? We need human experts, not only domain experts, but also programmers to achieve these tasks. So can we actually say that machine learning is learning from data automatically with this? Not exactly. So what I'm saying that machine learning experiments looks like that. First, and I will try to introduce to you some concepts and terminology. The very first one will be a machine learning pipeline. We will be talking a lot about those pipelines. You can see a pipeline as a series of steps. Okay? So the first one is to load and prepare your data. Very important. They are saying that you will spend 70, maybe 80% of your time here in stage 1, preparing data. which means that data is always messy or at least not ready to be modeled. Yeah? Then, based on this data, you will select or add some features. I will explain this later. Based on those features, so that's the first designing decision, or set of designing decisions. Then, how to represent the knowledge hidden in this data. Maybe using random forest, or support vector machines, or just logistic regression, or any other of those machine learning algorithms. Important decision. And you have to do this by yourself in front of, to start even this this machine learning process. Okay, for whatever reason, I'm saying logistic regression. Looks good to me. Then there are some hyperparameters. So all of those algorithms have some parameters that define the model architecture. Like, how many trees should I grow? Or what's the learning ratio? Or the penalty here, yeah? And some problems, some tasks, machine learning tasks, heavily depends on those hyperparameters. So you will get completely different performance, from completely useless to very good models just by tuning those hyperparameters. And finally, now that's the automated part, isn't it? Now I selected my machine learning pipeline, so it looks like that. Now I can start the automatic process of extracting knowledge hidden in my data using those algorithms. Probably I will build more than one model, so at the end I will have to evaluate and compare those performances. Looks like a lot of manual, hard work to do. And automated machine learning changed these approaches, and it's not new. Automated machine learning, or AutoML, has a long, at least 30 years of history, and many libraries are already mature enough to be used in production. There are also, most of them, like that's typical for AI, are open sourced. But I will use, as I said, Azure Machine Learning Services to show you how easily, right now, without any programming skill at all, you can perform this kind of machine learning experiments. Or still, if you are a Python programmer, the code first experience is also available. So it's up to you how you use this service. So the goal of AutoML is to change the experiment from the one I showed you previously to something like that. What you have to do is to provide data set. It's our original data, not prepared, cleaned, or enhanced. Just a data set. Then set some target, like, I would like to achieve 99% of accuracy. Okay? Finally, so this also means that you have to specify your tasks. Are you aiming for classification or regression, or right now that those two tasks are supported in Azure Machine Learning Service. And finally, it's good to set some constraints. Otherwise, you may spend more money than you wanted. Yeah? So I'm saying, okay, in terms of wall time, or CPU time, or memory available, I'm going to perform no more than 50 those experiments. So I'm going to build no more than 50 candidate models. And for each one, I'm going to spend no more than 10 minutes. Something like this. Now, the AutoML part kicks off. And all those manual steps are being automated. So, this framework will choose and test different machine learning pipelines configurations for you. And the idea is it should do this intelligently, better than you. Okay? Finally, you will get some models, and hopefully one of them, at least one of them, will be good enough to be used. So that's the core idea of AutoML. And Azure Machine Learning Service is the one that is relatively easy to use, and you can start for free. Free subscription will be needed. But actually, some core functionalities are just Python library. So just inside a Python library, so you can install this SDK to Azure Machine Learning Services locally and use it locally. Not all features will be available, especially in terms of scalable training in cloud and operationalization, which means deployment to Kubernetes service in Azure. Yeah? But this automated this data preparation and finding the best configuration, yeah, you can do this locally for small models at least. So, machine learning pipeline, the core idea of this session is you can divide this process into three main stages. The first one is about data. So data ingestion, that will be very easy with Azure ML. There is a concept of workspace. Probably you have been working with Azure this way or another, yeah? A bit. Some of you, have you heard about Azure? Okay. Let's check. It should be something like this, yes? So there is a workspace. I have my workspace, AutoML, and this workspace contains a default data store, and I can just upload my data there. And it will be available even if I'm going to scale out my training to any cluster, because I have some compute targets here defined, hopefully. Oh, okay? Like, I don't know, this one. Right now that I turn off, yeah? Actually, the subscription right now is like this, that you are not going to, I'm not paying for turn off clusters, so that's the reason. But as you can see, it's, yeah, from 1 to, I don't know, 8 nodes maybe in this case, yeah? Okay, so I'm going just to upload data to my data store, and it will be propagate automatically to those compute targets for me. Easy. Then there is a data preparation. And this data preparation has the goal is to extract features that better represents the problem to the machine learning algorithm, resulting improved accuracy on unseen data. So test error will be lower if you prepare your data properly. And it includes some standard techniques, if you think about this. So normalization. I can do this blindly. So if the feature, if a variable is in numerical, I can normalize it, even if I don't understand what does it mean. Some basic transformations can be done. For example, a date. Date by itself is useless, more or less, for machine learning, machine learning algorithm, but you can extract from it very useful and important features like year, month, quarter, okay, day of the month, day of the week. There's a huge list. The quality of data, yeah, that's the main problem, and you will have to deal with missing data. almost always, there will be some missing values. And you have to do something with this. And also, you can do this automatically. Like, you can replace all those missing values with means for numerical and with medians for categorical variables. Finally, I can extract some features. And this is the hard part, actually. Here, we, people, spending up to 80% of experiment times. This part is still not yet fully automated. But some work is done, and I'm going to show you that on the test data sets that I just downloaded data about risk management, credit risk management, it did a good job. So it worked fine. Because featureization is actually this part when the domain knowledge is useful. Yeah? If you understand your data, you will get better results, roughly speaking. The second part is about how to find the best algorithm and the best combination of its hyperparameters for a chosen feature set, okay? And this is something that can be relatively easy done in 3 ways, described shortly. And finally, the model deployment, so how to use it for production. In machine learning, operationalization means that your users should be able to send data to trained model and get those predictions back. Yeah? Predictions sent by this model back. And it can be not so trivial, especially if you are working in OpenR, to do this. Here, Azure Machine Learning brings you the power of containerization. So you can deploy your model as a Docker image, wherever you want, actually. So, this pipeline with Azure Machine Learning Service looks like this. First, you have to create your workspace. So provisioning a resource, easy. Then you can start working with this using, right now, the Python is available. Hopefully I will show you a code. The graphical interface, maybe some of you use the Azure Machine Learning Studio. Very nice tool to learn machine learning, for example. So this graphical interface is also available here. And the third one is called automated machine learning. And I will show you the screenshot from this automated machine learning interface shortly. As the name suggests, you have to apply your data, set your goals, and you can launch the experiment with this. Data preparation. Data preparation can be done using this AutoML data prep package, Python package, and that's it. So there is no graphical interface for this part. Nevertheless, you are able to check the quality of your data because some summary statistics and histograms are generated for you, at least. Experimentation. Now, you can train any model. It does not have to be a classical machine learning where data are in tabular form. You can do facial recognition or fancy stuff with recurrent neural nets here as well. As I said, the model can be trained locally or in Azure. There is even the nice feature called notebook VMs. So you can launch a virtual machine in Azure and use it to run with Jupyter's notebooks. I did this. Probably the easiest way to work with Azure Machine Learning Service. They are using a convention that the experiment contains many runs. So I'm defining an experiment, and then I'm launching this experiment, and that's my first run. As a result, I will get some models trained, and the performance of this model can be checked and compared There are nice graphs for this. The best model can be chosen for me automatically. Okay? This model can be registered in my workspace. So there is a management part for this. And deployed, as I said. And deployment, right now, for production-ready deployment, you have one choice, Azure Kubernetes Service, which means that the performance of this model can be monitored in long run. You can collect the input data, the data that users send to the model to get the answers, and based on this data, you can check the data drift. Because another common problem in machine learning world is that the performance on the model can get worse and worse in time. So right now, when I finished, it's very good. After 6 months, it's not so good any longer. Why? Because something changed in the data, yeah? And this data drift can be compared, measured, and by this Azure Machine Learning Service, and you will get a chart saying, okay, right now is the best time to retrain your model. If you don't want to use Azure Kubernetes Service, you can download this model, by the way, easily, and use it as you wish. Yeah? But you can also deploy it on the edge. So that means the virtual machine running Linux, yeah? Azure IoT Edge virtual machine. So that's my example. That's what I have done. Though this data is downloaded from a website, Loans Club. So it's actually the data that measured those loans in the United States for years. Quite extensive amount of data. I'm using my cluster to perform this experiment, saying that's my data set, that's the profile. As you can see, there's a lot of nice statistics. My task is classification, because I wanted to decide if this loan is a good or risky one. I'm not going to lend you money if you are not willing to pay me back. Yeah? That's the idea behind this classification. So there is a is bad output variable. And that's actually it. As you can see, I can click Start. But there was also this advanced configuration part. And with this, what I can say, I can constrain this experiment or this specific run of my experiment. Let me help you, because yes. So, as you can see, I left this metric score threshold blank for this demonstration, actually, because the Azure Machine Learning Service is so good that the very first candidate model is the perfect one. You know? Boring experiment. So I force it to build 50 models. Okay? But how to assess the quality of those models? You should not use trained data for this, because if so, you will not be able to detect overfitting. Quite common problem. And quite common solution to this problem is to use k-fold cross-validation. So leave out a small part of your training data and call it validation set and use it just for validation. And this is actually important because probably you know about this k-10-fold cross-validation. The hold-out procedure is going to be repeated, in this case 10 times. And the overall quality of the model is computed as an average. Okay, so I'm building 10 models using 90% of data for each of those models. the 10%, one fault, different for each run, is left out for validation. And this actually means that sometimes I can stop earlier this experiment, because now we are not talking about machine learning, but about AutoML. And AutoML is about finding those ML pipelines, yeah, the best one, in efficient way. So maybe after just the first fault used for the validation, I can say it's not going to be good enough. So I'm stopping earlier this part of my experiment. Okay. Now and then it's about scaling. Yeah. Easy. Finally, I can blacklist some algorithm. I'm saying, okay, don't use decision tree. I don't like it. I'm smarter than you. And that's it. Time to launch this experiment. And get some results. So as I said, data preparation can be, there was a checkbox, turn on advanced data preprocessing. If you check this on, this magic will happen. As I said, from the year will be extracted some useful informations. There are a long list of transformations. The most important are noticed here, but we are not going to describe them one by one. Let's talk about the second part of this machine learning pipeline optimization. And this part is called combined algorithm selection and hyperparameter, so cache problem. So how to solve cache problem? If you are building those machine learning models right now by hand, how are you finding? What do you do to find the best configuration, the best algorithm, and the best set of its hyperparameters? Maybe you have some insight. What should I do? Because the problem is that the number of algorithms is not that big, but still, number of hyperparameters can be the list of hyperparameters can be very long. Those hyperparameters can be real valued, integers, binary, categorical. There are some dependencies between those hyperparameters and parameters. Okay? So it's a relatively hard problem to be solved. How to minimize how to maximize the performance of my ML pipelines. So it looks like this. If you want some features, some algorithms, some hyperparameters, and my task is to select a few, and I got 30%. Not the best. So what's next? The same, more or less. Let's select other features and check. And again, and again. And in practice, most of those experiments looks like that right now. And this procedure can be optimized, actually. So I can achieve this faster, spending less money using AutoML. So what are my options? The first one is to solve this cache problem using grid search. Grid search is just a fancy term for brute force attack. So let's check every possible configurations. Quite costly, not used in practice. But we can start with the second approach is to use random search. Because most of those pipelines architectures will be very similar, yielding almost identical performance. So it's wasting of my time and resources to check them. Let's select at random a few. Also, relatively easy task. You can parallelize this task easily. So it's highly scalable approach. useful as a baseline. And now, the intelligent part. We can solve this cache problem. We can treat this problem as a regression problem. How to minimize my loss function based on hyperparameters values. Something like this. Okay? So it's meta machine learning right now. And this can be done. Azure Machine Learning Service is one of the features or one of the services that implement this very approach. So, to be sure, first, it's not only about evaluating of those hyperparameters. I also should take algorithms into account. But that's easy. The algorithm is just one more categorical hyperparameter. Cool. Then I have to do this for different features. So I'm preparing data in different ways, normalized this way or not normalized, or scale some variables and choosing some variables. And I have to do this algorithm and hyperparameter selections for those features. Yeah? That's my problem. And this approach, I'm saying here, this Bayesian optimization is quite good at fine-tuning, but it is relatively costly because I'm starting each run, so I'm checking each ML pipeline configuration from scratch. But actually, I should learn from previous experiments to be more effective. And this is meta-learning, okay? Meta-learning means that the results of previous experiments, not only mine, but also other people, can be used as a starting point. So there are meta features like the number of observations and some information about each variables, the problem itself, that can be used that my problem is more or less similar to other problems already seen by Azure Machine Learning Service. So let's start not randomly checking those hyperparameters and parameters and features, things, but based on those previous experience. Okay? Still not looking at my data, but only at those meta features of my data. That's the idea here. Microsoft Research published a paper, how it works. They are solving this optimization problem. Maybe you are more or less familiar with this concept of recommender engines. So recommendations. You can think about AutoML task as a recommendation problem. I should recommend you the best ML pipeline configuration. I mean machine learning service. Based on some metadata, my previous knowledge about all those experiments that were performed, I can assess or predict with some degree of certainty how good this model will be. Okay? This machine learning pipeline configuration. And it's working, they are doing this, not directly based on hyperparameters, but based on latent variables. So, one more pre-processing steps. It looks like this. The nice thing about this picture is that you can see that the performance, like accuracy of those models, is not randomly, it depends actually on those latent variables heavily. Yeah? It's better here, much worse here. So by finding this, I can launch my Bayesian optimization process, and I'm searching not the whole space, but only those areas. Very efficient process. And it can be even improved a bit, a little further. First, this early stopping, we were talking about this. Then, Probably you have heard about ensemble models. Ensemble models are quite good and commonly used to improve performance. It's a set of models working together. Here, the very last ML pipeline configuration proposed to you will be always an ensemble model, because it's for free. I already checked, built, and trained those different models. Yeah? They're probably the best. I already built like 50 models here. So now, I'm going to combine them and check the performance of the ensemble models as well. Nice optimization. So, looks like this. I launched this experiment. As you can see, I had 8 nodes in my cluster, but only 3 are going to be used, because at least at that time, I got this message that there are some quotas, and only 24 CPUs can be used for single experiment. I'm okay with this, no problem. So it's actually scalable, as you can see. So if you remember, 3 nodes in my cluster, so 3 models can be 3 ML pipelines configurations, can be checked at once, simultaneously. It's happening right now here. All others are queued or already completed. And that's the performance of all those models in terms of accuracy, because I choose this metric for this task. As I said, the first one got 100%. So I should say, if it's a perfect model, I'm not waiting any longer. But here, the chart will be quite boring. So that's the experiment history chart. You can select a single model and get more detailed information about this model. Even you can get some explanations. Maybe I will be able to show you. So, the nice thing is that Azure Machine Learning Service, I already solved this problem. So I built my perfect classifier. Now I am perfectly sure that I will lend money only to those guys who will give me this money back. Yeah, no risk. But now I would like to use this model in production, and that's the whole rest of Azure Machine Learning Service. So we were talking about this part mostly. But now I said this model can be registered and can be deployed as a Docker image wherever you want, or download it. You can even do this for your own models. So you can register model built outside Azure Machine Learning Service as well, if you wish. So this operationalization is pretty nice and can be used to not only with models trained here, but also with all machine learning models you train whatever you wanted. Okay, so a lot of information, but hopefully it looks like sensible to you. Now I would like to show you the other way, quite quickly. I have just a few minutes. So that's the different phase, the Python phase of this Azure Machine Learning Service. So not just click. And important part are here. I'm preparing my experiment, okay? And I'm loading data from Kaggle website about this Titanic disaster. So it looks like this, yeah? Some descriptive statistics. It's for sure, it's not easy to be modeled data at this stage, yeah? Like those names, stuff like that. A lot of missing values, but I don't care. I'm just saying, I'm even not sure. Maybe if I remove some variables, for sure I'm saying that my output variable is survived, and that's it. And this is my AutoML experiment configuration. So let's do check 30 candidate models. The best one is the one with the highest precision. Good. Bandit policy, so early stopping. And that's it. That's the one line, one function I had to call, configure, and now I'm submitting my run. The results are like this. So different ways of data preparation, different algorithm, hopefully different hyperparameters as well checked. And the best one, in this case, let's say voting ensemble. So as I said, the very last ML pipeline configuration will be an ensemble model. If I built already 30 good models, let's choose the best from those and build an ensemble. Maybe this ensemble will be even better. In this case, looks like this. 85% will give us pretty good score on this leaderboard on Kaggle without even looking at this data. So okay, that's those models. As you can see, there is a fancy widget, so you can work with on this using Jupyter Notebook in fancy way. There are some features built for you. You can check what those features were. Like there were a lot of things, a lot of transformation done to this name variable. And now it's testing, that's boring. But here, I would like to show you one thing. Let's check if I can go to a model here, or if not, I will try to do this here. Yes, 2 minutes, because there is one part I just briefly mentioned that right now it looks like a black box completely. It would be good to have some explanations about those models, how they actually work. And at the end of this chart, but not this one, sometimes I'm surprised. You should get if I did this correctly. Yeah? So if I actually set this explanation to true, there should be one more chart. Sorry, saying that those variables are more, or those features are more or less important for this predictions, for those predictions. Sorry. Yes, explainable AI implemented, yes, behind the scene. So, what I was saying is that there is a new way of doing machine learning using AutoML libraries, maybe AutoML services like Azure Machine Learning, which means that the whole experiment can be automated, at least partially. Data preparation, data enhancement, cache problem, optimization, so ranking and selection the best algorithm, and finally this explanation, also explainable AI, how it actually worked, what I did. Yeah? And there's a lot of nice notebooks ready to be used and extensive documentation. You can start playing with this. And actually that's it. Thank you for your time.